Okay, no joke, the best way to get better at proofs is just to do more. So here's just another example of one. Let's take a look. Now, what we've been doing are called two-column proofs, all right? Two-column proofs. And it's self-explanatory. The first column is your statements, all right? And the second column is the reason for your statements. And that's just a way of organizing the proof that in a very systematic fashion that will help you not lose track of the statements that you're making. So as normal, right here, they give us our, this says fill in the blanks to complete a two-column proof of the linear pair theorem, okay? And I posted the linear pair theorem for you up above here. And if you come on up, it is right there. Oh, there we go, I passed it up. Right here is your linear pair theorem, okay? And I'll just pull that out over here. We'll take a look at that as we do this. All right. The linear pair theorem says that if two angles form a linear pair, then they are supplementary. And that makes a lot of sense. Now, remember, a theorem is any statement that you can prove. Once you have proven a theorem, you can use it as a reason in later proofs. And you can just say, because of the linear pair theorem, these are supplementary or something like that. So let's look at a proof that proves this, though. So they're going to give you angle 1 and angle 2 form a linear pair. And notice what they did here. They drew out a possible linear pair. That is incredibly important. All right. Draw the hypothesis. That is really, really important. It'll make things so much easier for you if you can visualize it. All right. So angle 1 and angle 2 form a linear pair. That's a pair of angles that make a line. We wanted to prove that angle 1 and angle 2 are supplementary. And of course, with our definitions, we have to remember that supplementary means they add to, or sorry, they have a sum of 180 degrees. All right. Now, the nice thing about these proofs, which is different than it was when I was growing up, is they're going to give you a lot of the information, and you just have to kind of fill in the blanks right now. So the first statement, angle 1 and angle 2 form a linear pair. How do we know that? Well, that's given. Because they form a linear pair, what else do we know? Well, we know that ray BA, so from here to here, ray BA and ray BC, that's here and here, they form a line. They form a line. Got it. And how do we know that? That's the definition of a linear pair. If they're a linear pair, then that means there's two rays that form a line. The measure of angle ABC is 180 degrees. We can say that. Well, how do we know? Why am I allowed to say that? Well, that's the definition of a straight angle. Okay. If we have two opposite rays, okay, so that's two opposite rays. Now, this is a lot of terminology coming back to you. All right. If you have two opposite rays, they form a line. So the measure of angle ABC is 180 degrees because that's the definition of a straight angle. So now, what's the next thing we're going to be able to say? All right. What's the next thing we're going to be able to say? But they give us a hint. The reason, whatever it is we say, the reason we're going to be allowed to say it is because of the angle addition postulate. All right. So take a second and pause the video if you want and think about what you would say right now. Well, I know what I would say. I would say that if we're talking about the angle addition postulate, we must have been adding together two angles. So I would say that the measure of angle, oh, sorry, give me 1 second. I would say that the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle ABC. All right? And that is the angle addition postulate. And if I'd wanted to, I could go back and look up the angle addition postulate to see what it was talking about. And then I'd say, oh, yeah, that must be talking about angle 1 and angle 2. All right. And so now it says the next statement I'm going to be able to make, I don't know what the statement is, but the reason I can make it is because of the substitution property. And they get that based on steps 3 and step 4. So take a second and think about what we could put there. Now, the hardest thing about proof sometimes is how obvious some of these statements are. It's like, well, duh, I knew that already. But sometimes they want you to write it down. So what we're going to write now is make sure I don't screw this up myself. Is we're going to write the measure of angle 1 plus the measure of angle 2. That's 180 degrees. Why can I say that? Well, I know that measure of angle 1 and angle 2 equals this whole straight angle. And we also proved that the measure of angle ABC is 180 degrees because it's a straight angle. And so we can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And so finally, and that's because, and all we did was substitute these two, the measure of angle ABC for saying 180 degrees. And then finally, we can say the measure of angle 1 and, we can say the angle 1 and angle 2 are supplementary. And why can we say that? Well, that's just the definition. That's just the definition of supplementary angles. If two angles add together and give you 180 degrees, then that is the definition of supplementary angles. By definition, they add up to being 180 degrees. And that's how you would finish that one out.